Today we're going to learn object-oriented programming in Python as quickly as possible, so let us get right into it. Alright, now as always with these quick tutorials, I'm going to try to cover a lot in a short amount of time, so I want to cover a lot of topics considering object-oriented programming in Python. And I want to do that simply and concisely, which means we're going to go quite fast, and we're also not going to cover absolutely everything. So this is not a complete guide. This is just a jump starting video where you can watch, I don't know how long this is going to be, maybe 20 minutes or something, plus minus. And you're going to be able to watch this video and get an idea of what object-oriented programming is about and how to do it in Python. So let us get started right away. I'm going to go to my tutorial directory here, and I'm going to create a new file called main.py. Now, we're going to use only core Python here, no need to install any external packages, and I want to start by explaining the concept of a class and the concept of an object. Now, an object is an instance of a class. A class is, so to say, a blueprint or a description of what an object will look like. For example, I can say class person, and I can define what a person looks like. And I do that by specifying a couple of things, for example, a constructor where I can also define the attributes of the person class, but also other methods that kind of represent what a person object can do. So for example, the constructor in Python is called init, or to be precise, __init___. It takes a self keyword as a mandatory parameter, and everything then is optional. You can pass here some parameters like name, age, and job, for example. And the self keyword here is very important because it's a placeholder for the actual object. Later on, what we can do is we can create instances of this class. So I can say something like person1, an actual person, is equal to person. And then I can pass some values here like Mike, 25 years old, programmer is the job. And that is going to be person1. Now, since we don't have that instance yet when we define a blueprint, we refer here to the object itself, whatever it's going to be, as self. So whenever I do self.something, I'm referring to the actual object, to the actual instance of this class. So I can do self.name. Now I'm giving the self object an attribute name, and I set it equal to the name that was passed to the constructor. I can do the same thing here now for age and job. So I can just replace these values here if I can not mess up my typing. And now we have these attributes set to the parameters that were passed to the constructor. This here is what we need to be able to do something like this. P1 is equal to person. And now when I use parentheses here, I'm constructing the object. I'm using the constructor, which is the init method. So now I can do stuff like Mike, 25, programmer. Like this. This creates an instance of the person class. If I run this, nothing happens because I'm not printing anything, but I can print now p1.name. I can print p1.age, and I can print p1.job. As you can see, all of this is now set to be part of the p1 object. So now we have a concrete instance, a concrete object based on the person class. So the person class defines what is part of a person object, and the actual values and the actual behavior is then implemented here, or actually realized here by the object. Now I can also do stuff like, for example, get older. I can define a function that also takes self as a mandatory parameter, and I can say self.age plus equals 1, for example. This will make a person get older. So what I can do is I can say p1 get older, and then I can say print p1.h. There you go, 25, 26. Why does this work? Because we have self, but self is not being passed explicitly here as a parameter. Self is basically taken from calling p1 dot. So p1 here, in this case, it's self. So what it does is it takes the age of p1 and increases it by 1. That is the general idea here. Now we can go deeper. We can also override, or we can define multiple dunder methods. Dunder means double under for double underscore. We already have a dunder here, which is the init method, the constructor, but we also have many other dunder methods. For example, I can go and say __ string __, and I can define the behavior. First of all, let me comment that out and let me show you what happens by default. If I print p1, you can see I get some string here representing a person object at a certain memory address. This is not very interesting to me. So what I can do is I can override what happens when I turn my person object into a string, and I can say that this should return the following string. it should just be person, and then maybe, I don't know, these angle brackets, name, and then I can say self.name. And now when I run this, you can see person, name, Mike, and I can also print the other attributes as well. Now there is a second Dunder method here that is quite similar called the repr. So representation essentially, like this, underscore, underscore, repr, underscore, underscore. And it's basically also, if I comment out the str, you can see we get the same result, but it's not exactly the same use case, because if I have both, and let's say the repr function here or method here does something different. So let's say test, for example, I will still get person name Mike here. But if I go out of this program now, for example, and I open up a Python shell and I say import, or actually from main import P1, and then I just print P1 without printing and just specifying P1, you can see that the representation in the Python shell is now test. So this is how I triggered the repr, and by printing I trigger, so if I say print P1, I trigger the str. And if I don't override the str, it's going to use repr. So that's the basic idea. All right, so what else can we do with that? Let me replace all of this here and show you. I can, for example, define a class vector 3D. Very simple. I have a vector that has 3 dimensions, so x1, x2, x3. You could also say x, y, z. And now what I can do is I can overload operators by using specific dunders. Overloading operators means, let's say I have an instance here, vector 1, and I have an instance vector 2. What happens if I say vector 1 plus vector 2? By default, it doesn't work. It's not defined. We don't have this operation implemented onto vectors. However, I can do that manually by overriding specific dunders. For example, I can use the add dunder. In this case, what it does is it takes self again, and other can also be named something else. And what I have here then is I say if the instance of the other object here is also a vector 3D, so if it's of the same type, what I'm going to do is I'm just going to add the individual fields. x1 plus x1, x2 plus x2, x3 plus x3, and so on. Otherwise, I'm going to say it's not supported because I'm not able to add a vector to something else like a string or a float. So I'm not going to allow for that, but that is the basic idea. Now with this dunder, what I can do is I can take 2 vectors like this, and I can print what happens when I say vector 1 plus vector 2. Now, the important thing is I'm not going to really see much because I don't have a representation dunder implemented here, which means we're just going to get the vector object again. So let me briefly do that. I'm going to copy here the representation dunder, which is just printing x1, x2, x3 as a string. So now I can run this, and you can see I get 15, 30, 45, which is exactly adding these individual values. Now I can do that not only for addition, I can do that for subtraction, multiplication, and division. For division, we have true division and floor division, which is rounded. And you can see, or actually floored. You can see here I have sub, I have mul, I have true division. It's just a different dunder, and I do the exact same thing. I define what happens with the individual things. The idea is I take vectors in and I get as a result a vector. In the case of multiplication here, I implemented it with a scalar. So we have either a float or an integer. If the other object here is an instance of float or integer, I can just do it like this. I can just make the calculation like this, and I return a vector 3D object. Now, I'm not going to cover all the dunders here. I also have a tutorial series on advanced Python programming where I go into more details, but you can look them up. We have stuff like contains, we have stuff like typecasting, we have also equality here. So equality meaning how do I determine whether 2 vectors are the same? So v1 being equal to v2 can be implemented with the EQ operator. So in this case, I'm going to get wrong. Actually, I have some indentation issues. Now you can see it's false, but if I have, for example, the same values, so if I have a vector 3 that has the exact same values, and I say vector 3 being equal to vector 2, then I get true because I defined it like this. Now let us move on to another concept, which is inheritance. Inheritance basically means I can create a class not from scratch. I can build on top of another class. I can have a parent class, and then I can have a child class, which basically is the parent class, but also extended, so it has more attributes, more functions, or maybe it overrides certain functions. That's the basic idea. For example, here I have my person class again with a print name method, and what I can do now is I can create a second class called programmer, which here by putting person into parentheses inherits from person, which means now the programmer class also has name, age, and job as attributes. It also has the print name function or method, and it also has the representation dunder implemented, unless of course I overwrite these things. So here I can overwrite the representation dunder, and I have now this new behavior. And in the case of the constructor, what I do is I call super to access the parent class. So this gives me the parent class. Init calls the constructor of the parent class. So I still pass name, age, job here as parameters. I call the constructor of the parent class, which is person. Here I pass name, age, job. Then I have a new attribute, main language. This is what I treat separately here. And that is how we do inheritance. So what I can do now, of course, is I can also show you that this works. Programmer1 is equal to programmer. Mike 30 programmer C++ is the language Mike uses. Then we can print Mike's name, even though we don't have the function, or actually method. I always keep saying function. We don't have this defined in the programmer class, but it's inherited from the person class. And I can also see the main language, and I can also see that the representation dunder was overwritten. It is also possible to inherit from multiple classes. For example, I could have a class flyer, I can have a class swimmer, and then I can have a class flying fish, which inherits from flyer and swimmer, which means that this flying fish can now fly and swim. So I can run this, and you can see I can fly, I can swim. And then we also have something called polymorphism, which basically means many forms. The idea is I have a class like shape, which implements or actually does not implement the area method. And then I can have circle, square, and triangle inherit from shape. So shape now has different forms, literally, actually. And the area method is overwritten in all of these implementations. There's a different way to calculate the areas of the different shapes. But in the end, I have these shapes here, and I can just call the area method, and we get the areas calculated in different ways. This is polymorphism. Now, is this everything you need to know about object-oriented programming in Python? Absolutely not. There's much more to learn. This was a very quick and dense introduction into the subject. If you want to see a similar video with similar pace and similar density for more advanced concepts like data classes, encapsulation, name mangling, properties, static methods, class methods, and so on, let me know in the comment section down below. Also, let me know if you want to have a more in-depth course, maybe 1-2 hours on object-oriented programming in Python. Also in the comment section down below. And besides that, of course, don't forget to hit the like button to subscribe to this channel and hit the notification bell to not miss a single future video for free. Other than that, thank you much for watching. See you in the next video, and bye.